All right. We are complete, I think. You can hear me fine?
Yes.
That's good. So, welcome to the presentation about the Decorator pattern. As Mike mentioned this morning, one which I inherited by a colleague who unfortunately can't be here today. So let's see how good I can talk about that topic, but kind of confident. So my name is Lutz Fechner. I'm the little brother of Mike. So for everyone knowing Mike, I'm his shortest brother. There's one in the middle even more. I joined consulting work 3 years ago as kind of mixed role. So I do project and delivery management mostly, and also some, let's say, non-ABL projects. So if anything touches us from more Java or .NET side of things, I'm usually involved there. That is because I have no strong ABL, Progress, Open Edge developer background like most of the people in the room have. So don't ask me too detailed questions about ABL. So I'm more .NET and Java guy. Since I joined consulting work, obviously I also work with ABL nowadays. I did a lot of development in the e-procurement side of B2B business, so marketplaces and especially the search engine part of that. So kind of developing things like eBay-ish applications. So short notice about consulting work. I guess there are many presentations, so I don't have to talk too much about our company. We are an IT consulting organization focusing mostly on Open Edge and any satellites around it. So other progress tools like WhatsApp Gold, for instance, we can help you there too. We are located in Cologne with offices also in the UK, nowadays also in the USA, and we have a development office in Romania. Our customers are basically around the globe. There's a big chunk from Europe, but also people from America, Australia, and also South Africa. So some of them are also at this PAC this year. That's what I meant. So if we don't only cover the Open Edge itself, not everything, but many of the supporting products that Progress acquired over the years, we also work with them. I'm skipping that. You will hear that many times this 3 days. So about this talk, we are going to talk about a software design pattern, which is called the Decorator pattern. Before that, talk a little bit more about what design patterns are in general and where they are coming from. And then we go through an example of what to do with a Decorator. So software design patterns, it says there it builds on the foundation of object orientation. That's not 100% correct. There are many design patterns which are not for object orientation. But the ones we are talking today, or the one that we are talking today, that is a pure object orientation pattern. Software design patterns are like, well-known ways of solving problems that you see many times when you develop software. And what they do is, by following that pattern, make the software that you write easier to understand so that other people can read and understand what was done there. And because usually they tend to provide cleaner code to the code base, makes it then easier to maintain and correct if something's wrong, or to extend. I mean, if there's some ununderstandable bunch of classes that you inherit from a former developer that already inherited from another development team that was acquired by whatever, you find that in legacy applications, that there are dark areas, no one really knows what it does. The better the code was designed, the easier it is to understand for third-party people getting in and reading that. Yeah, basically, also it prevents that you reinvent some pattern on your own that is already available for the problem you're going to solve. So many design patterns, especially for object orientation, are or were promoted by a group of people that is known as the Gang of Four. That is some people that worked for rational software. Rational software was, or is, they are kind of still around, but acquired by IBM, I think, some decades ago, maybe nowadays. They were very early in object-oriented design and analysis, so the people working there also work basically on UML, which is the description language or modeling language you use for object-oriented design. I think most of them are still around. I think one died. It's basically a gang of three nowadays. And I hope they all are retired and living a good life. So there are some examples of patterns that are well known. There's factory, builder, singleton, facade, adapters, and so on. That is basically patterns that build on the foundation of object orientation and make it more usable. Before going to that, so I just discussed that in a break with some of the Baltic Amadeus guys, that at least the way I was taught object orientation, that only went to, let's say, the foundation level. Classes, interfaces, encapsulation, inheritance, polymorphism, and stuff like that. And that's it. Then basically, trained software developers are sent out in the wild and suffer their own life. From my point of view, at least some very common patterns should also be included in professional software development trainings. So, because they are rudimental to creating clean code, which keeps maintainable and easy to understand. So one of them is the Decorator pattern, which we want to talk about now. So basically, this is a Wikipedia quote. In object-oriented programming, the decorator pattern is a design pattern that allows behavior to be added to an individual object dynamically without affecting the behavior of other objects from the same class. That's nice. And I think also the UML class diagram there doesn't help that much to understand what's going on there. So we will go over a real example, what is key to this thing. So basically, to translate what it's saying there, it's more or less an alternative approach to inheritance for extending the functionality of an existing class. At runtime, that means extending the functionality of a living object. It allows to follow the single responsibility approach or principle from the solid principles. So you can make extensions or decorations to a class without modifying or multiplying other classes. Allows extension without modification. That is the actual decorating thing. And it's very flexible way at the runtime of your application to change the behavior of the object that you're dealing with without creating a different object and basically initializing that again. So no casting, extending, or overrides needed. We will see how that works. So there are a few key components to using this pattern. One is an interface, which should be or has to be common between the class that you want to decorate. So that's the decorated there, and the decorators. So they all implement the same interface. And the decorator will hold a reference to the class it's decorating, or actually to the object that it's decorating. So it's like a wrapper that changes the behavior of the object at runtime. So there was an example, or there is an example that I, in the short time, brought up that we use today. So let's think about, we have a class that represents a house, like a house where people live, and that can tell you how much energy it consumes over the year. And with the decorator, we will be able to change the calculation of the energy consumption at runtime without modifying the actual class. So for that, we define a very simple interface, and you can also use it in. Why doesn't it switch me? There. We can switch to the Progress Developer Studio, and we have an interface which we will be using for a class that is let's say the base implementation for that, and that implements that interface that we had just saw. No, don't switch me to the other columns, pages. So, and then we want to modify what the energy consumption of that house is. So let's say we can change the energy consumption of a house by insulating it. Then it will use less energy. So if we look at this is a decorator called insulated house, and it implements the same interface as the, let's say, normal house or basic house. And the method here, get end energy consumption, that is different, or let's say it's changing the behavior of the other house, let's say, because it's taking the house that it's decorating and more or less changing the energy consumption returned. So one key point in the decorator pattern is the decorator class here. In the constructor, it will get a reference to the, let's say, to be decorated object. And we keep that reference. And when we call the, let's say, decorated method, we forward to the original unmodified, and then we change the behavior. I mean, we could do here whatever makes sense, but in this example, I'm forwarding to the original house and modifying the behavior. Okay, then it goes to the real example. Let's say there's somewhere a demo. So the demo basically creates a basic house and then outputs the basic energy consumption. Then we decorate that house with an insulated house and ask again for the energy consumption. And the cool thing about those decoration things is you can have multiple decorators decorating the same thing. So here we created a decorated house that we will decorate again. So first we added insulation, then we changed the heater from gas to heat pump, and at the end we add solar. And it's always more or less chaining the decorations. So we will always give the house that we return back to the next decorator. I can also launch that, see if it works. It's a little bit small. So the basic house that had a energy consumption of simply returning 24,000 as integer, and the insulated house was taking that and basically pretending it's now only two-thirds of the energy used before, and the heat pump divides that by 4, and the solar installation removes, I think, a fourth of the remaining consumption. And if you look at the implementations, they all decorate the same way, let's say. They all implement the same interface. They have a constructor taking something that is also implementing that interface and keeping a reference to what was given. And when you ask it for the energy consumption, it's forwarding it to the house received and doing whatever modification it thinks is needed here. If you look again at the demo, where is the demo? There's the demo. You can basically decide at runtime how the behavior should change. So here it's changing from basic to insulated to heat pump to solar powered. If the reality is that there will be no heat pump, the house is just insulated with solar powered, you use a different or no decorator at all in that case, or just the ones which you think are there. This is like configuring the behavior. You could do that at runtime with, let's say, checkboxes in the GUI, and then you decide when calculating what to show to the end user, which of the decorators you run or add to your class. If you run it now, the output then is different, obviously. If you want to do something like that with classical inheritance, so let's say you want a house with heat pump and solar, implementing or inheriting from the basic house, you override then the method that you want to change and then do all the changes. So this thing here is intended to do 2 modifications. which is then done in the method here. This is unflexible, so you can't do that at runtime. This is hard-coded. I want these two modifications to happen in the overridden method. In the declaration, you can decide at runtime which calculation you want to change and which not by adding the decorators. That is the neat thing about the decorator, the runtime modification without the need for a class that defines that. So that's the let's say, worst example, which I showed you. And the thing is, with the three modifications that I wanted here to be present in this example, like solar, heat pump, and insulation, that is 2 by 3 variants that you could have. So that means if you had, or would be going the classical inheritance route, you would be adding 8 inheriting classes with changed behavior instead of 3 decorators. So you save classes, it's easier to maintain, you can do it at runtime. That's actually a very neat pattern to keep your code cleaner and the runtime more flexible to do dynamic modifications. So yeah, as I said, you can basically chain them. So you can use the decorated object and decorate that again. You save classes at the end. And that's more or less it from my side. We have a more complex example available on GitHub. So github.com/4glfanatics. That is talking about airplanes and seats and configurations. It's basically creating a configurator for tickets that you could buy from an airline. But the principle obviously is the same. Just a little bit more complex, so I simplified that to make it easier to present for me. And we will continue with the decorated classes here in a session. Actually, it says on Friday. That's a lie. It's tomorrow. Let me change that. So on Thursday, we will use the house example to do 2 things. One is building a factory for houses. That sounds weird. And also creating a builder for houses to make creation of those objects nicer to developers. Any questions so far? Mm-hmm.
You only want to insulate your house, so only the energy consumption method you want to change that. You have to implement the 19 others to just...
You would have to forward them to the original one, yeah. Mm-hmm.
In that, I agree with the decorator stuff, but in that case, just extending the clause would be kind of less work because you just override one method. Now, I see where you get it. You have like 4 or 5 options, it explodes it, but you would have to implement all those others by hand too.
I guess it depends on what you expect, what your software will look like in the future, or if you need the dynamically changed behavior at one time. Because this thing is nice. Let's say you have a GUI with some checkboxes and you click them and then add the corresponding decorator to the object that you use as your base to change what calculations are done. If that doesn't make sense for what you're trying to do, then don't use that pattern. I mean, patterns are not suitable in every situation. Some are overkill, some are unnecessary, some are not the right fit for what you're trying to do. So maybe your example is not a good example. Because you're right, if you have a right interface and you decorate it with this pattern, you will have to, as stupid as it is, forward everything because you are forced to implement it in your decorator because it has to follow the same interface. And if you don't implement any, I mean, you have to. It doesn't compile if you don't do. What do you want to do?
Yeah, maybe the interface is too big. The eye and solid.
Oh.
Segregation.
Okay. Look, there's another pattern. Or principle in this case. Yeah. No questions? It's a rather simple pattern, I have to. But it's neat. I mean, the outcome of how clean the code looks and the option to change at runtime without casting, inheriting, whatever, that is cool. Is it already beer time? Okay. Yeah, then thanks for the attention. And see you next time. Look, it even says the questions go to Peter Judge, please. Yeah?